All right, let's apply this concept of the average value of a function to maybe a more complex function. And in particular, if you're familiar with the mean value theorem for integrals, it kind of describes how to find the average value of a function in a roundabout way. And so I'm not going to go into the mean value theorem. You may want to go review that if you don't remember it, but we're going to use it for sure. And the key to this particular video, I wanted to make sure before you clicked on it, you knew that the integral that we're going to have to do involves substitution. Okay, so that's kind of a spoiler alert, but here we go. We need the average value of this function, which we're not worried about graphing it. We just want the average value. And we know this function is continuous everywhere but at x equals 0. And so it is certainly continuous on this closed interval from 1 to 4. Okay, so that's important because the mean value theorem for integrals says if this function is continuous on the closed interval, then we know there's a c such that we know there's a c inside that closed interval where f of c times the width of the interval, 4 minus 1, equals, so this is the area of a rectangle, equals the area under the curve from 1 to 4. In other words, the integral from 1 to 4 of this function e to the 1 over x squared dx. Okay, so the average value that we're looking for is this f of c. We know it exists because the mean value theorem guarantees it. So I just want to point that out first of all. Now furthermore, not only does the mean value theorem guarantee it exists, it shows us how to calculate it. In fact, this f of c is the average value, and to solve for that average value, we simply divide by this difference, which is 3. So I'm going to take and divide both sides by 3. Now I could write the integral over 3, but it's going to be easier to write 1/3 times the integral instead of writing the entire integral all divided by 3. Okay, so that's what I'm opting to do here. And so now we know exactly how to find the average value, right? This f of c is the average value, and here's how you calculate it. Now it's just a matter of evaluating the integral and multiplying by 1/3, and that's it. So let's get down to business. Now, if I want to integrate this, it looks like kind of a tough integral. However, hopefully you recognize there's some ways you can rewrite this. If you're if you're doing integrals and you're kind of a beginner, let me rewrite it in a way that maybe can help you understand. So 1 over x is the same thing as x to the negative first. And x squared, dividing by x squared, is the same thing as x to the negative second. So I can write this as x to the negative second, that's the same thing as 1 over x squared, times e to the power of x to the negative first dx. Now I'm not saying that looks better. However, when we're getting comfortable with integrating and differentiating, it's nice to write things as powers of x when possible. Okay, so what we can see here is if I let my u, because I'm going to do this integral by substitution, if I were to let my u be x to the negative first, then my du, the derivative of that, is going to have an exponent that's 1 lower, and it will contain x to the negative second, which is necessary as a component of this integral. So that's what we're going to do. So I'm going to let u equal x to the negative first. Okay, so when I'm reconstructing my integral, my e to the x to the negative first just turns into e to the u. So I know when I reconstruct it, it turns into e to the u. What remains is x to the negative second dx. Okay? So this is u. Let's go ahead and figure out du. So if I differentiate both sides, I get du equals, on the right side I apply the power rule for derivatives. So I drop my -1, make it a coefficient. So I got negative x. My exponent drops by 1 and turns into -2, and then dx. So du equals negative x to the negative second dx. But as I said, I've got highlighted over here in green, I need to reconstruct x to the negative second dx. So what I need to do here is get rid of this negative, because I'm trying to isolate this stuff here so that I can put whatever it equals back into my integral in terms of u. So divide both sides by -1, and I can see that negative du equals positive x to the negative second dx. Therefore, I can replace x to the negative second dx with simply negative du. So what I'm going to do is throw my du on here, and I'm going to throw my negative on my coefficient, so that's now -1/3, and I'm going to bring down my integral. So my negative du covers my x to the negative second dx, and my e to the u covers my e to the x to the negative first. Now what I'm going to prefer to do is, the original integral was in terms of x. The limits of integration were in terms of x. What I'm going to do is change my limits of integration to be in terms of u. That way I don't have to go back and change everything to x and then plug in my 1 and 4. Okay? So I need to know the corresponding u values for these x values. Well, here's the definition of u. So if x is 1, u is 1 to the negative first, which is 1. So my corresponding u value for 1 is also 1. That's lucky. Now, if x is 4, then u will be 4 to the negative first, which is now 1/4. So if x is 4, the corresponding u value is 1/4. So my upper limit of integration did change. All right? But now I've got a much easier integral to do here. So I bring down my coefficient, -1/3. I integrate e to the u with respect to u, which we know is e to the u, and then I evaluate that antiderivative from 1 to 1/4. Okay? Well, we're almost there. Remember, this is the average value of our function. We solved this for the average value, which is the same thing as f of c. So now I need to carry my coefficient. I need to plug in 1/4 for u, so that's e to the 1/4, minus plug in 1 for u, that's e to the first, or just e. And this is my average value. You really can't do much simplifying here. I know it's not satisfying. It looks ugly, but it's a number. The exact average value of that original function is -1/3 times the quantity e to the 1/4 minus e. Now, if you want, you could approximate this to see what number we get. And let me grab my calculator here so I can do that real quick. So -1/3 times e to the 1/4 minus e. It looks like it's about 0.478, just to give you an idea. Okay? That's the approximate average value of this function. That's the approximate average height of this f of x function from 1 to 4. Okay? And so that's how simple it is. It's a matter of being able to do the integral. That's the hardest part. And understanding how to get to that average value. If you can do the integral and you know how to get to the average value, then it's no problem. Okay? So I hope this example was useful. I didn't want to do just another basic example showing average value, because then if you go to do homework and you have to integrate something harder, then you may be thrown off. Just understand, use whatever techniques you know about integration to do your integrals. In this case, it was substitution.